Hi, welcome to Joyce's classroom. I am currently teaching a geometry class in a community college, and this is a short winter session. Decided to pick some important examples that we actually go over in a classroom, and then make a video here. In the first lesson, let's look at counterexamples and sets. Example 1. Find a counterexample to show the statement is false. A counterexample is an instance that shows this statement is false. Remember, this statement says for all number x and y, this statement absolute value x plus y equal to absolute value x plus absolute value y. This tells me this is always true. But if I found one instant, x and y, where this is false, then that will be a counterexample. So let's consider one example where it's non-example first, non-counterexample. So non-counterexample, let's think about two numbers. I'm going to let x equal to 1, y equal to 2. Again, I want to give you an instance where I see a lot of students do in class, where they say, well, just let x pick a number, x and y, and see what we get. Then, it follows this statement. My left-hand side of the statement is, left-hand side, I'm going to deviate this way, is equal to absolute value x plus y. That is equal to absolute value 1 plus 2. And that is equal to absolute value of 3, which gives me 3. And the right-hand side of the statement is x plus absolute value y. That is equal to absolute value 1 plus absolute value 2. That is also equal to 3. Notice that this statement, I have 3 on the left-hand side. I also have 3 on the right-hand side. So they are equal to each other in this case here. They equal to each other cannot say prove that the statement is true. Counterexample is to use to show a statement is false. So therefore, I notice that since they equal to each other, I can't really say that this is a counterexample. So I say this is not a counterexample. Not a counterexample. Again, I want to look for x and y such that make this equation false, this equation here, the green part here, I want to make it false. So let's try another one. Okay, so let's consider x and y again. So I'm going to let's pick x equal to 1. Again, you can pick anything you want here in this case. And let's remember that absolute values of a negative number are going to give me positive. So I want to pick one and then to be negative to make this statement false. So let's pick x equal to 1. Let's pick y. Let's make y equal to negative 3. Then, the left-hand side of the statement becomes absolute value of 1 plus negative 3. That is equal to absolute value of negative 2, which gives me 2. Let's look at the right-hand side of the statement. And inside the statement, I have absolute value of 1 plus absolute value of negative 3. And that is equal to 1 plus 3, which gives me 4. Notice that 2 does not equal to 4 here. So this is a counterexample because 2 does not equal to 4. This is the instance that the given statement is false. So I make the conclusion. I say, therefore, the given statement is false. One statement is false and by counterexample. That will be example part 1A. Okay. So when you found something that that's true, that's not a counterexample. Be careful there. And that means you need to find something else to make it not true. Now let's look at part B. Okay. Part B says for all numbers x, square root of x squared plus 16 equal to x plus 4. Again, I'm looking for a number x. So when I substitute x into the equation, I would have a not true statement. I want a not equal to here. On the left hand side, not equal to the right hand side. Okay. So let's let there are many possible scenario here, many possible answers. So but let's pick one. Let x equal to, I don't know, let's see, a small number. Let's say make it 3. Okay. Then let's look at the left-hand side statement. In this case, I have hand side is square root of x squared plus 16. I'm going to substitute the x into the expression. I'm going to use a different color. So we'll have 3 squared will give me 9. 9 plus 16 is going to give me 25. But I have square root of 25, which give me 5. That's the left-hand side. Now let's look at the right-hand side of the statement, which is x plus 4. Again, I'm going to substitute x equal to 3 in that expression. I would have 3 plus 4. In this case, I have 7. We know the 5 is not equal to 7. Therefore, this is not equal. Notice that 5 does not equal 7. Therefore, this was a counterexample. So I can make the conclusion. Therefore, in many textbooks, you might see a lot of people use the 3 dot to mean the same thing. Therefore, it means the same thing. Therefore, the given statement is false by counterexample. Given statement for all x, square root of x squared plus 16 equal to 4 is a false statement. It's false by counterexample. Okay. That will be part B. Okay, we just finished the counterexample lessons. Now let's look at sets. Before we actually find the union intersection, let's recall. So when I look for union means this symbol. So the union of, let's say, A and B, any two set A and B, tells me I'm looking for elements in both A or B, in either A or B. So it consists of elements in A or B. And this symbol here, A intersection B, the intersection with upside down U here, kind of look like, looking for element that's common to both sets of A and B. Element that are common in A and B. Okay. And then another one that you see quite often is called a complement. And in complement, we usually put a dot for the implied complement. This means you can read this as a B complement, or you can read it as not B. Read as B complement or not B. So in this sense here, we look for elements that are in the universe, that are in the universe U, but not in B. Okay. So those are the definitions for union, intersection, and complement. So now let's look at question A. Okay, I'm going to erase this and then look at question A. So question A asks me to look for B union C and then intersection with A. So kind of think of it as auto operation here. I have parentheses B union C. Someone do B union C first. Okay. Again, B union C. The union tells me look for things that are in B or C. So this is equal to, okay, things that's in B or C. And B, I have And B or C, this is my B, this is my C. So things in B or C will be 3, 4, 5, 6, 7, 8. So 3, 4, 5, 6, 7, 8. Note that I'm going to write each element only once. Next one, I'm going to look for A. I'm going to put A below here so that you can see side by side. Okay, so this is A. And the elements in A, the set A, consists of 2, 3, 5, 6, 2, 3, 5, 6. Now, I'm going to look for the intersection of these two sets here. So I'm going to intersection of A. No, let me use a different color. A. And the intersection of B to B union C. So that means I'm looking for elements that are common to both of them. So I say, well, common, 2 is only in A, it's not in the first one. I know that 3 is in common to both of them. I know 5 is common to both of them. I know 6 is also common to both of them. So my intersection set of these two are 3, 5, 6, and that's it, 3, 5, 6. Okay, and that will be my final answer. That will be A. Let's do one more, the involving complements. Okay, B complement. Okay, first thing I'm gonna look for B complement. Well, B complement means I'm looking for, again, things that are in the universe but not in B. So let's look at our universe. Our universe is right here. This one is our universe. Let me use a different highlighter maybe. Okay, this is my universe, and this is my B over here on the highlighted part. So things in union in the universe but not in B. I could simply just cross out, look at the union, cross out things that are in B. So know that B has 3, 4, 5, 7. So 3, 4, 5, 7. These, take it out, it become my complement of B, which is all B prime. So 1, 2, 6, 8, 9. Okay. That will be B complement. And then I'm going to look for A intersection C. Again, I'm looking for elements that are common in both A and C. So I'm going to remove all the highlights and look at it again. So I'm consider A and C. So A is this one, C is this one. I'm looking for elements that are common to both of them. So they're common to both of them. I see from these two sets here, A has 2, 3, 5, 6. C has 5, 6, 7, 8. I know that they both have 5 and 6 in common. So therefore, 5 and 6 is in the intersection. So the A intersection C has 5 and 6 in it. Okay, that's how I get that part. Now let's look at the union of these two sets. And so let me write it. So I have B prime or B complement union A intersection C. Okay, I am looking for the union of these two sets, the first two here. So the union of this one and the union of this one. So union tells me I'm looking for things in either one of those. I see that 1, 2, 5, 6, 8, 9 in either one of those. So therefore, my union contains 1, 2, 5, 6, 8, 9. Okay, and that will be my final answer for the sets. Now let's look at one application question. This question I seen them in geometry class. I also have seen them in like some statistics classes as well. So pretty common question, I think. Now let's look at question this here, a survey preferences. So the director of a school has surveyed 150 students. It tells me that in the survey there are 150 students participated. So my universe is 150 students that participated in the survey. The survey results are shown below. It says 65 students like volleyball, 75 students like basketball, 15 students like both volleyball and basketball. Now the question asks, of the students surveyed, how many students like volleyball but not basketball, like basketball but not volleyball, do not like neither one of those sports? So to do this question, it's kind of easy to do it using a Venn diagram. All right, so this is a picture of Venn diagram here. So here I'm talking, there's two sports involved, basketball and volleyball. I'm just going to label one basketball, one volleyball. So let me label this one a volleyball. Okay, I'm going to label this one basketball. And I'm going to label different regions. I'm going to call this region A. This is my region B. I'm going to call this region C. This is region D. Okay, so region A represents students who likes volleyball but not basketball. Region B represents students who likes both sports, which is common to both of them. Region C represents students who likes basketball but not volleyball. Region D represents students who doesn't like neither one of those sports. So let's try to fill in the blank for those regions, see how many like each. So let's look at question A. Before we do question A, let's try to see, is there anything here I can fill in the regions with a number? We know that 15 students, we already know one of them, likes both volleyball and basketball. That means I know 15 already. So 15 must be over here. So 15 students like both sports. Now, question A asks me, how many students like volleyball but not basketball? Well, I know volleyball total is 65. 65 students who likes volleyball. So I know 15 of them already likes both. So to find A, I could just say, you know what, region A, which is the first region here, plus B should give me 65 because 65 students like volleyballs. So I'm going to solve for A. I know B is 15. So I have A plus 15 is equal to 65. Now subtract 15 to both sides. When A is equal to 50. So 50 students likes volleyball but not basketball. So this is 50 students. Okay, you could put equal sign. Let me just put 50 here. Okay, that will be part A. Now let's try to figure out part C. Part C again represents student who likes basketball but not volleyball. Again, we can do the similar way like we did for part A. So I know that for basketball, there are 75 students who likes basketball. Well, so that means there's a total of basketball. So that is equal to region B plus region C. Let me use the same color, consistency. So B plus C is give me the total of basketball, which is 75. Now, I said, well, we know, B is 15 plus C is going to give me 75. Let me leave this one in green. Okay, now I subtract 15 to both sides. So I would have C is equal to 70 minus 10 give me 60. So 5 minus 5 is 0. So 60 students who likes volleyball but not basketball. Okay. All right. So far we finished. We figured out all the regions. Now let's look at D. Again, D represents students who likes neither one of those sports. So maybe student who doesn't like sports. Okay. So again, we know the total of students who participated in the survey is 150. That means if I add all the regions up, A, B, C, D, I should get 150. So let's do it. So I have A plus B plus C plus D gonna give me 150, which is the total number of students who participated in the survey. And fill in the thing we know, so this is 50 plus 15 plus 60 plus D is only one that I don't know. In this case, is equal to 150. So let's kind of add the left-hand side before we solve. So here, 50 plus 15 give me 65. 65 plus 60 gonna give me 125. So 125 plus D gives me 150. Now I subtract 125 to both sides. So 150 minus 125, you should get 25. So D is equal to 25. So 25 students in the survey do not like neither one of those sports. Okay, so D in this case is 25. Okay, and we just finished this question. All right, thank you for watching the video and see you next time.